right, welcome back everybody for the third and last day of the webinar. The most exciting day too. We have some really nice stuff for you today. So let's dig in. So first of all, a summary of what we did yesterday. We mainly looked at data management methods to help you optimize, once again, optimize your Grasshopper definitions for cloud applications. First, Edwin presented some tree strategies to gain performance and also, make more readable, more compact definitions. And then we introduced JSON objects, which allow for flexible and really really easy to use communication tools with web applications. So today, Edwin will give an overview of what we'll do.
Yep. So today we will start again with challenge number 2. So we had this list of points that we were creating through sliders, and then the challenge was to change this with a JSON structure. We had one participant that shared his script in the forum, so I will try to use that one to answer the challenge number 2. And for today, when we start our topics, we will start with the standard native GH inputs that you can use. So the Grasshopper inputs that you can use to send information to your online application. Then we will look into file inputs, so more complex information that you want to send, images, geometry, and text. Then we will look into nesting, drawings, and exporting, so how to generate production data from your Grasshopper definition and send that to the user of your online application. And finally, we will see the final result in ShapeDiver.
Yes, exactly. So, as usual, all materials will be available in our forum, especially today. We'll have the answers of yesterday's challenge and basically the final Grasshopper file for the table that Edwin will talk about today. So that will be available right after the session. And once again, a reminder about communicating. Please use the Q&A interface for questions. We tend to miss some in the chat because there's a lot of activity there. Some polls again today to help us orient and paste the content. And yes, between this, so after the session, you can still contact us on the forum, on our website, anywhere. And we will have this, the full 3 sessions of the webinar available mid to last May, to end of May on the YouTube channel. But for today, let's get started.
Let's get started. So let me share my screen. Okay. So thanks again for everyone that is joining today, the last day of our webinar. To begin with, we're going to answer yesterday's challenge where we were changing our list of points with a JSON structure. So here, if we check the version 1 of our table, in version 1, we had this list of points that is created with some sliders. So we check here where the information is coming from. It's from these sliders that we have here. And then, of course, that limits our interaction with the model in the online application, in the cloud application. Therefore, we wanted to change this with a JSON structure. The JSON structure is very similar to what we saw yesterday in the session, where we actually created some points, and then these points are an array, so a list. And then this list has some objects which contain attributes that are, in this case, coordinates, that is X and Z. I don't include here the Y because in this case we want the Y to be always 0, but it could be included as well, of course. So here, when I input one of these JSONs inside my definition, then if we check the model, then we can see here the 3 points that are created from this JSON. And then here, this is the last points that we, so here I'm processing the JSON. Remember that you will get this definition after this last session, so you will be able to explore it. But basically here I'm processing the JSON, getting the information as we saw yesterday, getting the points, the X and Z coordinates, and then with that I construct my points, and then I get basically the same 3 points that we had in version 1. The only difference is that now we have the control, we have more control through our online application, because we have everything structured in a JSON, which can be edited easily through the online application. So if I change this with another JSON, so for example here we have 3 objects, 1, 2, 3 objects, but in this one we have 1, 2, 3, 4, 5, 6 objects. That means we have 6 points, and then we can see how that will affect our table. We'll add like a bit more of control points, and then the user will have more freedom to do additional stuff with the design. Here we have like 4 control points, I believe. Yeah, so basically you can start changing your JSON structure to get different variations in your online application. So if we check the forum, in the forum we had Pedro, he shared his definition, his attempt to create this day challenge, the second challenge. And he actually also started to play a little bit with the API. This webinar is not about the API, but it's glad to see that there is people already working on improving their skills with the API as well. So if we check here, he has his definition, his definition, which is actually quite fast, because it's just a test with the points. And then even he has some logic. So if I put this point far away, the logic always brings this back to a limit. So it doesn't go all the way like whatever you want, but it has a limit. But basically you can start changing all of this, and all of this lives in the Grasshopper definition he shared. So if we check here, JSON control points, this is his definition, Pedro's definition. Here is his JSON, which is similar, the same basically. He just includes the Y coordinate here, that what we just saw. And again, the same thing, he's accessing points and then accessing X and Z coordinates to finally get the general points that we have here. That then, from this, he gets some spheres. We need these spheres because we need 3D geometry to be able to make this draggable effect in our 3D application. So we need these objects so that they can be dragged, and then of course he also displays the curve. Here I just want to explain that there is, again, there is different ways that you can structure your JSON. Therefore, for example, here we have a list of objects. So a list starts in JSON starts with a bracket, starts and ends with a bracket, and then we have the different objects, which start with curly braces here and here and here. So these are objects. But here you could do a similar. You could get the same result with a different structure. Here, for example, we have a list of lists. That means we have a list here, the starting here, ending here, and then instead of having objects, we have other lists with 3 numbers. So in this case, we know that these 3 numbers are the X, Y, and Z coordinate. So if we parse our object, and then we access the points of our object, then instead of getting, so here when we access the points, we had a list of objects. So as you can see, it's an object with X, Y, Z attributes. Here, instead of getting that, our JSON component already detects that you have a list inside a list, and basically that transfers to Grasshopper as a tree, and then we get a tree structure. And then with this tree, we could, for example, in the JSON, we have something called the ShapeDiver JSON convert, as we saw yesterday. You can input this here, and this converts directly to the points instead of going through getting the Z and the X, etc. So it depends on how you want to set up your JSON. And finally, Pedro asked how to make different curves. So we have here we have one curve with different points in this structure, but we want different curves. So several curves with points. So we saw that in our last example yesterday. So you can check that in the file, the definition file of yesterday's session. This is the same thing that we saw yesterday, and the only thing that I have here different is Well, if we display this on, then we can see our loft surface here. I'm gonna preview of these ones and preview on these ones. So here we have the different control points for different curves. So here we have everything graphed so that each sphere can be selected independently. So if we have every of these spheres in different branches, that means that they will kept as independent meshes in the viewer. And then we have a list also here that contains the addresses of my points. So which each of these points to which address belongs in our JSON. So we know that the point in the branch number 00 here belongs to the address curves 0.0. So we know exactly when I drag this point where it belongs in our JSON. This component is called the ShapeDiver Data Output, and it's something that we will check today. So that we can, this is basically data that we are sending to our online application. And that's it. Any questions so far regarding the challenge?
No, not yet. So
Perfect.
you can move on to today's topics.
Perfect. So let's go to today's topic, third day. So until now, what we've done is we already have a optimized definition. We already have a optimized definition which can access complex data structures, in this case through JSON. And we also gave some tips and tricks to keep your data trees organized and also to use them for optimization. But now that we have, let's say, the perfect Grasshopper, now we need to connect this Grasshopper to our application. So we need to be able to send information to our Grasshopper definition and also to receive information back. So that basically we do the same that we are able to do locally in our machine. So to do that, first of all, we are going to look at what are the native Grasshopper inputs that we support. So this is something that we support internally at ShapeDiver in the platform. And there is reasons behind it, like, for example, why we don't support a panel as a text input and all of that. We will check that out later. So these are the ones that we support. So we have here a slider and a control knob. So that in our online application, that translates to a slider. So both of those, a slider and the other one, the control knob, both of them get converted into a slider that then you can start moving in ShapeDiver to start to edit your online application. Then we have the color swatch and the color picker. Both of these ones gets translated in the website, gets translated into a color picker as well, a web HTML color picker. And then here you can also get different colors as you will do in Grasshopper. Then the next one, you have a toggle. So this also gets converted into a toggle in the HTML part. So here we can also, for example, we have this option to hide all geometry or show all geometry. And then we have value list. So value list is where is like a drop down, and that's what we get here. We get a drop down. In this case, this drop down selects a material, metal or any other material. These are static materials that we have. And then we have this value list as a checklist. So if you right click on the value list, you can get different type of value lists. And in this case, you can also get a checklist. And with a checklist, you can check different values at the same time. So here we have that also turned it into a checklist that gets converted, that gets shown here in the online application. So here, for example, we have different types of geometry, that a box, a plane, and then I can start hiding or showing the different geometries that I have here. Of course, this is just an example. Here you can see the example. This is the example that I'm showing in ShapeDiver, where we have sphere, box, plane, cylinder, the scale as a slider, the hide all geometry as a toggle, and the color picker and the drop-down menu. All of this gets converted then into HTML menu items that you can actually access through the browser, and then accessing that way the Grasshopper definition. So you can of course do whatever you want with these traditional, let's say, native Grasshopper inputs. But then just being able to control this is quite limiting if you want to really go and expand your Grasshopper definition so that it can start to get very complex information, other kind of data like images or text or meshes or curves, etc. So if you need to also be able to send this information to Grasshopper, then that's when our plugin comes in, the ShapeDiver plugin, and then we have all of these special inputs that you can use to send other kind of data to Grasshopper. So we're going to start with some image data. For that, I first of all want to know, how often do you use Grasshopper to manipulate bitmaps? Very often, every now and then, or hardly ever? Let us know, please. And here, if you remember, well, we used this definition in our first day where we created a perforated wall. Here I have the perforated wall already optimized. So if I check the view, we can check the final perforated wall, and then we are using the C# script that we described on Wednesday, where we showed that you can actually just bake transformations in your geometry and then make those transformations in the online application instead of sending all of this geometry all together directly to the online application. So we explained that on Wednesday. And here, the only problem that we have right now is that we have this image sampler, which takes local files. So if I double click this, this gives me the information. Like this is the normal image sampler that Grasshopper has, and then it gives me information of the domain of my image, and I can also select another image if I want. The problem of this is that this is local. This is not. I cannot put here information that is coming outside of my computer, or I cannot connect information through an online application. And that's why we create our own image sampler and our own ShapeDiver Image Input. So first of all, you need to input your information into Grasshopper, and then you need to process it. So in this case, that's why we have this, that is a ShapeDiver Image Input. You find it into Inputs, and then here we have the ShapeDiver Image Input. And this one will allow you to import images into your online, into your Grasshopper definition. So if we double click this component, we see here which image types we support. We have all the list, and we can even uncheck some of them if we say, okay, I just want to receive some specific file type. If you want to check all of them, then you can receive any of these types. And then also the maximum file size, you can also limit this size. There is anyways upper limit. This is the upper limit that we support. Anyways, because you don't want to give the opportunity for your users to send very, very heavy images, because that's also not very optimal for the online application, because then you will have a lot of pixels to process. In this case, we try to give a limit to the user. So here you can put the maximum file size limit, and then in that way you make sure that the images that get sent are not huge 4K images. If that happens, 4K, 8K images happens, you anyways have to do some pre-processing before sending this, for example, to an image sampler, or maybe an image sampler is not that much of a problem, but we will see here down below that other components will create a problem if you have a huge image to process. And to make this smaller, like say to compress this image, you can use, for example, a Squid ShapeDiver edition, where you can process these images. So for example, here I could here if you go to instructions, we have the image instruction, and here I could redraw my image, but in a smaller scale. So here the bounds can be a rectangle that is a smaller scale, and I can keep the same ratio. by using the image, the imported image width and the imported image height that my ShapeDiver input image input offers. So so after we have this image inside Grasshopper, so you have here right now file path component. This is taking a local image that I have in my computer and then downloading this image into Grasshopper. But I have also here, for example, also a URL, an image that is on the internet, and then I can also input that URL in my URL input, and then my image is now not coming from a local file, but now from this URL. This URL has to be a public file, a public URL, otherwise we won't be able to access this information. Then when we get this bitmap inside, we can process this image with our ShapeDiver image sampler, not with the normal one, because again, because we have to support information that is coming outside of Grasshopper, then we have to create the special components that are able to support these file types that come from outside of Grasshopper. And this component works quite similar to the normal image sampler. So you have a bitmap, an image that is coming again from outside of Grasshopper. Then you have coordinates. So basically, it's these same coordinates that we have here. We're putting coordinates, and then the domain. That the domain is the same thing that we have here in our in normal image sampler, where you actually specify a domain for your image. In this case, we specify also domain, the same kind of domain, 0 to 1 and 0 to 1. And then when we input this into our color input here, so basically we just replace this one. Now we're using this other dog that is coming from this URL that I showed you here. So this is the URL that is coming from outside of Grasshopper, and this is the one that is coming from the local machine. You can also, for example, here put this component that we have in ShapeDiver. In the input, we have something called the ShapeDiver Text Input. That means that this will be shown in the online application as a text box. So if we check here, we have a text box, so I can start writing something here. In this case, what I want is a URL. So of course, it's not going to work because what I want here is a URL. So this component generates this text field, and then that allows the users to be able to put information in there. So in this case, I have to give a name to my component. So if I right click, I have to give a name. So upload your image as URL, for example. And that name, if we put this in the other way, that name will be shown here. That's the same name that gets shown here. Upload your image from URL. And then you can input this inside your ShapeDiver image input, and this will download the image from this URL. If you double click this component, you can here also give a default text value. So it could be empty, or it could be, for example, a default URL that you have, and also the length that you have, the maximum length that you have for this component. So in this case, the maximum that we offer is I think 10,000 characters. But then we have other components that allow even bigger strings, even bigger file text formats. In this case, we normally use this component either because you want to send a URL, or for example, if you want person to put here, the user to put here, for example, their name or something specific that then gets shown in the configurator. So for example, a ring where you want a name to be shown or a text to be shown in the ring, then you will add this component in your definition where you put here your name or put here your text, and then here they will write their text. This text gets sent to the Grasshopper definition, and then here in the Grasshopper definition you can do here you will get, for example, here I'm getting as output the default value that I have here, but then here I will get the text that our user is sending, and then I can process this in the way that I want. And also, this component, the ShapeDiver Image Input component, it generates also this upload button. So people can actually click on it. This is generated just by adding this component, the ShapeDiver Image Import component. Just by clicking this, I can now use look in my computer for a file that I want to upload in the online application. So in that way, you give the user two options: either they have their image in a URL, or they can simply click and find an image in their files. Here, for example, if I take this image, if I go right click, copy image address, then I paste this URL here in my upload your image from URL. The first thing that you have to have into account is that, first of all, this component, so this component that we have here, the ShapeDiver Image Input, gets priority. So if you have a file here already, then this one will be used instead of the URL one. So if we check back here, for example, I still see the same image because I have here a file. So if I delete this file, so I'm getting rid of this file, then I'm gonna be getting this information from the URL instead. You can access this definition right now if you want. If you can go to ShapeDiver. You don't need even an account. You can go to ShapeDiver, app.shapediver.com, go to Browse Models. And in Browse Models, you can see all the public models that our users upload every day. You can put, for example, my name, and then you will see the different files definitions that I have uploaded and play with them. So, for example, here we have the perforations wall and other definitions that I have uploaded for testing or for actual projects. So that's for the image one. Can we have the result about how often do you use Grasshopper to manipulate bitmaps?
Yes, as for last week, most people are not very used to working with images. And actually, one of the questions here is which plugin is Edwin using for manipulating bitmaps. I'm not sure that's what is exactly meant, but basically there's some tools in the ShapeDiver plugin that Edwin just showed to import images, and also the image sampler that works with ShapeDiver. But also Edwin will present the Squid plugin in a bit that allows to go a bit further and actually manipulate the images inside Grasshopper.
Yeah, here in ShapeDiver you have the components that will allow you to access information and input information inside your Grasshopper definition. And then if you want to actually manipulate the bitmap, do something with it, then you have two components that we offer, the ShapeDiver Image Sampler and the ShapeDiver Image to Mesh, that we will check right away after this. And we have also the Squid ShapeDiver edition. This is very good component to manipulate images, create bitmaps from scratch. And the reason why we have a ShapeDiver edition, because there is also a Squid, the normal Squid, is because, again, we had to make this plugin compatible with bitmaps that are coming from outside of the Grasshopper definition. So that can work with not just with local files, but also with files that come from the cloud. Any other questions or comments?
It's just a simple question about the maximum size of the image from the image input. What's the unit of that? It's actually, so it's not exactly 10 megabytes, but it's in bytes. So so if you see, it's like written in bytes, so it's very precise. But it's pretty much 10 megabytes is maximum for the size of the images you input in the definition.
Okay. Yep. Any other question?
No, that's it.
Okay, perfect. So here we have another use case for using this ShapeDiver Image Input. So here we have the same ShapeDiver Image Input. Here we have that we are bringing this image from this URL, and here with the Squid ShapeDiver edition, you can use this quick preview component, and with that you can see a quick brief preview of what you are importing inside your Grasshopper definition. And then here we're using another component that we have in ShapeDiver. It's called the ShapeDiver Image to Mesh component. And this will take this bitmap and, as it says, convert it to a mesh. So each pixel that you have in your image gets converted into a mesh quad. So if we go to Control M, we can see this is basically a grid grid of quads that are the different pixels in our image. And then here you have some filters that you can use. So for example, here I'm using the brightness filter. So basically I'm just taking the pixels that are the less bright, so all the black ones. And that's why here, for example, all of this part is actually not being converted into a mesh. That also saves a little bit of time of computation, because otherwise you will have even a bigger mesh here. And then you have other filters, the red filter, green filter. So for example, you could have an image with different colors, but you just want to take the red pixels of this image, then you could filter them here. In this case, I just want the very dark pixels, and that's why I put this domain from 0 to 0.3. Then I have my mesh, and then with that mesh, well, it's up to you what you want to do with it. But the good thing is that now it is a 3D object. So now we can affect this mesh with geometry, basically. So here, for example, we have this C# script that basically gets the mesh naked edges. We have also in Grasshopper, it also has its own component called the mesh edges component, but it is not as optimal, especially because it gives you everything as lines. So this gives you everything as exploded lines. And then when you take your mesh edges and then you join them, the combined of both components computing, it takes longer than just our C# component that actually looks for the naked edges in a more efficient way. This was actually scripted by our CEO. Then with these curves, then we can, for example, in this case, I just want to get the outside curve. I don't want to get everything, just the part that is outside of it, the biggest curve that I have. So that's why I take the bounding box, I take the area, and then with that I sort my curves by area, and then I take the biggest one. Why I take the biggest one? Because I want to use this in our riffs table. And then I have here some processing tools that have a Grasshopper. So I take my curve, and then I can, for example, smooth it out so that it is not all sharpy. I mean, of course, this is very sharp like this because we are working with pixels. So nothing is completely curved. Everything is pixels. And then what we can do is try to smooth our polyline and get something more like we have here, like an interpolated curve, so that it is more smooth down. There is also a component called Rooster. This is a third-party plugin. This is not our plugin. It is really good as well. It takes a path and then it converts this directly into curves. And as you can see, the curves are quite clean. We are going to support this component very soon. The reason is because we had to again create a version for ShapeDiver, because here this just supports local files, local paths, and we wanted to support files that come from outside of Grasshopper. But this will be integrated soon to the third-party plugins that we support. And then, for example, if I take this part of the definition and then I copy it and put it in our riffs table, then I could take instead of taking just the circular shape that we have always worked with, so this circle, we're gonna now try to use this shape that is coming from a bitmap. So if I take this one, I have here processing imported shape. So I put this inside this group, and then now our table takes the shape of our image. Here, the reason why I'm processing it is because, again, now we are receiving information that doesn't come from Grasshopper. Therefore, we don't know this geometry really. Any user could put any kind of bitmap inside here. So we always have to make sure that we simplify our curve. For example, in this case, we simplify our curve. We put it in the origin. So here I move it to the origin, then I scale it to 1 unit, so that then I can scale it up and down depending on my control points. And then in that way, our curves become from something unknown, something that we don't know anything about because it's coming from outside of Grasshopper, to something that we can control more, where we know where is the seam of our curve, what is the scale of our curve, the position, etc. And with this, we can start to do different processes in Grasshopper. So in this case, for example, we use it for creating our table. But actually, we have something more stable, let's say. This is more user friendly because especially if you have a lot of users, because normally, well, for people it's very normal to work with images in everyday life. They can go to Google, find an image there, and they'll just put the URL or upload an image from their computer, etc. But we have something more specific if you, for example, can work with DXF files or OVJ files, so files that are more complex, that not everyone has them, but they are more precise. And that's what we are going to use here instead of our image. Anyways, this image one, for example, could be used for other purposes, like, for example, the very famous parametric fin walls that is very well known in the Grasshopper community. The people is all the time doing fins walls. And here, for example, somebody could upload their logo. So they upload their black and white logo to your definition, and then with that you can get the outlines of the logo, and then process, for example, as you can see here in the back of this fin wall, and then make this fin wall go a little bit deeper so that you can see the logo in this fin wall. So that's an idea, for example, of how you could use this image input and then convert this image into a geometry that you can use to affect your definition. But here in this case, we're going to use this component that is called the ShapeDiver Geometry Input. It is again in the ShapeDiver plugin, and here we have the ShapeDiver Geometry Input. So if we go back to the third day.
And before you move on to the other types of inputs, I just wanted to correct what I said earlier. The default maximum size for images as input is 10, but actually the maximum is 40. So you can go up to 40 megabytes for images. And actually that's the same limit for all types of inputs. So now Edwin will introduce geometry inputs and later maybe text file inputs as well. And the limit for all of these file inputs is 40 megabytes in all cases.
Yeah. Is there any questions so far?
Yes. Are all Squid components compatible with ShapeDiver? As long as you use the version of Squid that we adapted for ShapeDiver, which is included and gets installed with the ShapeDiver plugin from version 1.6, you'll be fine. The only two components you can't use are the save and read components, because they're meant for playing with local files. So if you use them for local testing, you should just remove them before you upload your definition.
Yes, so you can use them again. You can use them locally, but then when you upload them to ShapeDiver, you have to delete them. Otherwise, the definition will be rejected. Okay. Any other questions?
No, someone asked for the definition that you're playing with, but I think you didn't upload it yet, right?
Which this one?
Yeah.
I mean, all of these will be sent after the session. Yes. All of these files get always shared. So, for example, the files that we used yesterday, they are in the forum. If you go to the forum, here we have the webinar day 2 challenge, and here we share all of the files that we used. And of course, people is also talking and let us know what they have done, if they have questions and all of that. But here you can download all of those files. And then we will do the same today, including the Rift's final version.
Yes. Okay. I will post instead, to answer this question that's in the Q&A right now, I'm going to post our because the question was about, the explanation about how to input images with URL and upload buttons. And we have a tutorial file for this in our support website. I'm posting the link to this Grasshopper definition right now in the Q&A.
Okay, perfect. Any other question, or can I continue?
No, you can go ahead.
Okay, perfect. So now we have another poll for you. What kind of geometry do you normally reference in Rhino to then manipulate in Grasshopper? So when you come here and you have some geometry inside Rhino, what normally do you import inside the reference inside Grasshopper? Do you do cures, meshes, B-wraps, or all the above? What do you normally manipulate? Let us know. Matthew will help me with that. Perfect. And now, so as we know here in Grasshopper, we have the power of, for example, creating a curve right now here on the fly in Rhino. So I can create a polyline, a curve, or any other kind of geometry, and I can come here, right-click, set one curve, and then I have my curve here. The problem is that, of course, a user in your online application won't be able to do this. So that's why we create a ShapeDiver Geometry Input, where you can actually have two kind of files to be imported, DXF or OBJ file. Again, here you can, by double clicking this component, you get this window where you can check or uncheck depending on what information you want to get, and also the maximum file size. And this gets translated also into a clickable element that you can have in your UI, in your user interface in the online application, so that somebody can upload their own file. It also supports the same URL input here, so you could again combine it with the ShapeDiver Text Input component. So you could combine it here, and then you could have upload your geometry or upload your geometry as URL, for example. Here in this case, we have this bunny as an OBJ file. Then it gets downloaded inside the definition, and then here we have the mesh as output. We can see here the bunny that is coming from a URL outside of Grasshopper or Rhino. It's coming completely from outside. And then with this, what you can do is, of course, whatever you want with your mesh. For example, here we have this definition that was created by Daniel, one Grasshopper developer that was working with us was doing his internship with us. And here you can see, for example, that you have here different models that you can use, hand, a heart, for example, and then this is actually a mesh, a normal mesh, and then it gets processed and converted into a Lego structure. Then you can also come here. So this clickable button appears when you add this component, the ShapeDiver Geometry Input. This gets translated into this menu item that you can click on, and then I can come here to my files and find, for example, this OBJ file that I have here of a bunny. This is the same bunny that we just showed here, this one. And then this gets converted into this Lego figure. And then here you have other options as well that you can play with, but this is other idea that you can use to use all of these tools that we offer to input information inside your Grasshopper definition. So what was the question what was the answer for our second poll?
Yeah, people seem to be referencing curves mostly.
Yeah. So that's perfect. That's perfect because we support the DXF file type, so you could import DXF to your definition. And something very cool that we support right now is that here you have also a material output, and in this material output, if you import a DXF, you get the color list of the curves that you have in this DXF. So, for example, you could have a DXF that contains the floor plan of a house, for example, and then you can say that all of the black curves in this floor plan are the walls, and all of the red curves are the columns or the beams or any other information. And then with that, you can sort your input geometry. So here you have a list of curves and a list of materials, of colors in this case. You can sort them by color, and then you can start processing in a different way in the different parts of your definition. Yeah, so that's for the ShapeDiver Geometry Input. Any questions so far?
Nope.
Perfect. Then we are going to continue with the text file inputs. So for the text file inputs, I want to know when you need to work with databases, in which format are they stored? Are they stored in Excel sheets? Are they stored in CSV files? Are they stored in JSON files? Let us know.
I added the XML option as well because
Okay.
some people use that.
Perfect. So this, the reason why I'm asking this is because we also have this component called the ShapeDiver Text File Input, where you can actually import a file type to the definition. So in this case, for example, if we have here the component ShapeDiver Text File Input. Again, it's coming from here, ShapeDiver Text File Input. If you double click on it, then you can see the text files that we support, the text files types that we support: plain, CSV, JSON, XML. So you can have all of these imported into your Grasshopper definition, and you have also the maximum file size. The same rule applies here. With this, you get a clickable button where you can upload your text files, and then you can also combine this with a normal text input. So this text input, as we saw, generates this text field where you can write directly in the online application, whereas this one actually uploads a file itself. The reason why you want a file is because, for example, if you have a product and then you have a database that contains something like that, like product name, product 1, 2, 3, blah, blah, all the names. You have product code, all the codes, you have the description of your product, and then you have the price of your product. Then, for example, somebody is using your online application and you don't want to just process the geometry, but you want to also process how much this costs. This is an example, or any other kind of information. So you can import this into your Grasshopper definition. For example, here in Google Sheets, you can go File, Download, and you can download this as a CSV type file. So CSV type files are very common in spreadsheets. And then you can import here, have this file path prepared here, and then you can import your text inside here, and then this gets converted into text that you can start to process inside Grasshopper. So if I make this panel bigger, we can see here that we have the same information that we had in this spreadsheet, and then it's just in CSV format, that is with commas separated. So you can see each comma separates each columns that we have. So here is the first column, here is the second column, and here is the third column. So we have all of them separated here. And then with that, we can use the normal Grasshopper components. So if we go to the sets tab, then here we have text processing components that the Grasshopper has. And then you can use those ones to start to process your text. So for example, here I divide everything by the comma. So I have all my columns separated. And then when I get here the output, then I have now everything here organized in the Grasshopper type. So with data trees. And then here in data trees, we have everything separated with each column has its own branch. In this case, for example, this is the first column, the second column, the third column, and the fourth column. And then with this, you could, for example, have a drop-down menu in this case where people could say, okay, I want product 7. And then with this product 7, you could find the information inside your spreadsheet. Here, for example, we have this same JSON that we saw yesterday. And then you can send these JSONs in two ways. You can send these JSONs with the normal text input here. You can send this JSON where you can actually input here your JSON. So you start your JSON, you end your JSON, and you start to put here how your JSON looks like. That's a way. That's one option. The problem of this is that, of course, if your JSON starts to be very complex, then sorry, can you still hear me?
Yeah.
Okay,
No
I heard something weird. So sorry. So with this, if your JSON starts to be very complex, then you don't want to use this text file input, this normal text input, because then it becomes too much information to interchange with your online application. If your JSON is very big, then you would use the ShapeDiver Text File Input, which also supports JSON. Here, for example, I have this same JSON as a file, and then I can do the same, put this inside, either as a URL or as a file type, and then as an output, I guess this JSON that then I can process as I would do normally. So I would parse this with my JSON, I would parse it, and then start to access my JSON as we saw yesterday. That's an option. So for example, if we see this definition where we have this huge JSON, it's a very, very big JSON, then the same happens. So here you would actually get this JSON as a file instead of as plain text. You will need this JSON as a file to be able to optimally in an optimized way to interchange information with your online application. Yeah, so that will be for the text inputs. Any questions so far?
Yeah, let's look at the results of the polling, and I'll make a few comments. So, you know, a lot of people work with Excel sheets, of course, especially because there's a few plugins that you can use for Excel interoperability. We don't support them yet or have our own tools. We're looking at the best ways to work with Excel files. But yes, mostly right now you'll be limited to, you know, so convert to a CSV or these other formats. So what's good is that all of these, like Ezekiel showed, like Edwin showed, CSV files can be processed easily with native Grasshopper tools. So all these text tools that Edwin showed. For JSON files, we have, you know, our own components to process them and even build them. So that's also a convenient way to work with data. And XML files actually are also convenient, and you have tools to process them in a plugin we support on ShapeDiver, which is Lunchbox, I think. Lunchbox or FabTools, I always confuse which one is what.
I think it's Lunchbox.
No, I think it's in Lunchbox. You have XML processing tools, so you can extract information from XML. So those are all convenient ways to import, export data, and you know, manipulate it inside Grasshopper. Yeah, so that was for the text inputs, and we had a question. We can go back for a second to geometry input. When you import a DXF, is the curve information the only information that can be extracted?
Is the curve information, the color information, do you refer?
No, yeah, so the geometry information, I mean, you can answer for both the OBJ and DXF formats. Right now, for DXF, I think or can you get the colors for DXF? I never...
Yeah, I explained that.
Okay, so yeah, you can, but you can't get all the metadata that's included in the DXF besides the color for now. We'll extend this, and especially because we'll extend to other formats, so 3DM, for example, and import more metadata about colors, attributes, and all of this. For now, it's mostly meant for pure geometry, so meshes and curves, basically.
Yeah. Any other question?
Nope.
Perfect. So far, until now, we've seen all the inputs, all that we could send to Grasshopper, either as a file or as a geometry, as a text, as a number, etc. All of this is information that we are sending to Grasshopper. But now we need to also process this information and extract it from the definition. So now that we have the inputs, now we will look at the outputs, how to extract information from our online application. So the basic one, the first way to do this is with the ShapeDiver Data Output Component. This component takes data, as it can be as a tree structure as well, and this data is in text format. I mean, in any text format, so including JSON and on other text formats. And basically, we take, for example, this example that we had here of this spreadsheet. We could get from it. I put here my tree, and then I put here what I'm looking for. So I'm looking for product 5. So this basically separates, this split tree separates my first column. So here I have my first column, which has the names of my products, and then with this member set, I'm trying to check where my information of product 5 is stored. So in this case, it's in index 5, and with that I can get the information from the rest of the spreadsheet. So I can get from here the code of my product 5, the description of my code 5, and the pricing of my code of my product 5. So in this case, for example, I can put the ShapeDiver Data Output, put this information directly in this output, and then you have to give it a name. So for example, I put here product data. And then this is information that can be then accessed via the API. So this information right now that you cannot access via the UI, but you have to, the user interface, but you have to really use the API to access this information. There is other ways to access information as well that we will show later. This one is the basic one. And you could also, for example, create JSON from this. So we saw yesterday the JSON construct component, and in that way you send your data in a more organized way for the application. So for example, here, if I construct a JSON from this, so I have 3 items here. I know that my first item is code, my second item is description, and my third item is price. So if I put this inside my data input, then I get a JSON object which contains code, description as price, and then I can put this inside my product data output, and then this will be accessed as a JSON format in our online application. So just as a quick overview of how this works, this is not, of course, this is not meant. This webinar is not meant for use of the API, but for actually the use of the Grasshopper definition, but so that you know how actually the web developer, or if you are the web developer, would start to access this data. They will go, for example, API that scene. So that means that I'm accessing the API. Then I'm going to the scene of my online application. Then I go get data. So I'm extracting information, and then in that data is where I would put my name, the name of the information that I want, and that's why it's important to give always a name to all, recognizable name to all of your components. And then inside here, I would put, for example, product data. And then in that way, I can get all of this information that I just processed via Grasshopper. I go, okay, this is what the web developer will normally start to work with, and then that's why it's important that you have a clear communication with the web part of the web application, and also the Grasshopper part. So if there is a great communication, then you know what are your inputs and your outputs and how to communicate between them.
Yeah, so that's the same story for the parameter names, of course.
Yeah, the same story for the parameter names. All the names, you need to give a recognizable name so that not just your users can know what to do with that, but also via the API you can recognize everything. So that's the basic one, but we have also a more complex one that is called the ShapeDiver Export Download. So this component allows you to download information, not just as geometry. Here we have a geometry, but because we used to support just geometry, but now we support all kinds of formats. So for example, here you can see the geometry formats, so 3DM, STL, DXF, DWG, etc. Text formats, image formats. So all of these are files that you can then export from the Grasshopper definition. So you, for example, import an image, then process the image, and then you can download the processed image. So for example, in our refs table here at the end, we have three actually. We have three options where we can download. We can download the production files, the 3D model, and the 2D drawings. And that's created with this component. So when you add this component here, this option is added to the UI, to the user interface. And also here, of course, you will put whatever you want to put here. So for example, here I can put just this JSON. Of course, it's a very small JSON. I wouldn't put this into this kind of output. I would put it in a more output like the normal ShapeDiver Data Output. But if you have a very complex file that you want to export, then you can put here that. Then you would put the format here, so I know that this is format JSON. And then I can put also the name, so the name that my file will have. So in this case, test or whatever other name that you want to give it. All of this is also inputs. No, all of them can be also parameters. So for example, you could have a value list, which contains which format do you want to download? Do you want to download this file? So for example, that's the example that we have here, where this is a value list, where actually the users can select in which format they want to download the production files of this table. Do they want any DWG, in DXF file, in 3DM file? The same how with the 3D model, where you can download in OBJ, STL, etc. So all of that can be in a drop-down menu, for example, for this one, and also the name could be a parameter if you want. It's up to you. All of these are just inputs that you can use as you wish. So that leads us to our refs table, and to start looking at the nesting of our table, so that we can export this information. Any questions so far?
No, you can go on.
Perfect. So here we have our fourth question, that is, have you ever worked with products that require nesting to generate the production files? Yes or no? So here in our refs table, we're going to start to nest this, so that we can see how to then put this inside our export component, our ShapeDiver export download component, and then get this information from the online application. So for the nesting, we're using a third-party plugin. It's one of the best that we have found for nesting, that is called OpenNest. If we go to Food for Rhino, we can check here the plugin. So here is the plugin of Food for Rhino, OpenNest, and here we can see different examples of how this is being nested. And here, what I want to explain is how to make your nesting as optimized as possible. So of course, nesting is a very computational expensive things. How you say, a computational expensive process, and therefore we always put a toggle for this kind of events that happen just at the end of your model. So for example, here somebody could be changing the model of this table, but you don't need to be nesting all the time. You don't need to be nesting every single time that somebody is changing something in the model. You just need to nest at the complete end when they are ready to export. That's why you have this process nesting toggle here. And then when you go through, then this will actually activate the nesting of our table. And check here. Here it is. And then, of course, this is taking 4.5 seconds to compute. And then I will explain how this works to make it, to make it fast. I mean, even though it's 4.5 seconds, it's actually quite optimized because of how we did it. So first of all, here as an input, I have a list of surfaces instead of a list of curves. The reason why I do this is actually it takes a bit longer to compute with surfaces, but the benefit of it is that the plugin can detect whether there is holes inside pieces, and then you can put inside of those parts other pieces. So you can compress more and more your nesting. So for example, here we have a piece inside another one. That's what we show. That's what is shown here as an example, where you have all of these nested inside our other shape, and in that way we can of course save material. Because again, if I would put just here, so if I go for example with the normal one, I'm gonna just don't import this image. So I will put here, because right now I'm importing my shape from this image that we show as example. So if we go back to the normal circle, we can see here our nesting. Some of these circles are inside the circles, so for optimizing. But if I were to put this as curves, then everything will be laid down separately, and then of course that wouldn't be very optimized for the nesting itself. Then the second thing that I do is actually I create here some geometry that is especially created just for nesting. So if we check here the tabletop for production is a circular curve, but the tabletop for the nesting is a surface which is a polyline, which has the less complex your geometry is, the faster it will be nested. So here I convert it into a polyline, and then I also give it as less points as possible. So the less points I have, the faster it will compute. This is more, you can see this more in our legs, so creating columns. So we have here the legs for production. You can see here how they look with all the notches, but all of these notches are not really necessary to be sent to the nesting, because of course we know that there is no a single thing that will fit inside here. Therefore, I create another version where you don't have that. You have it completely plain without any of those details, and you also make it a polyline, and you also make it you give it less resolution than what you would do with your final nest files. This is just used for nesting. So here I have my final nesting with all the geometry that is simplified, but as output I get in this component something that is called the transform. So I get the transformations that each of these pieces had to get to come here to this position. So here I know that I know the order of my list. So I know first I put my tabletop, then I put my columns, and then I put my riffs. And then when I have here my output transformation, then of course I start to split my information. So I know that the first item is regarding the tabletop. So I have here my original tabletop, the actual one that I want to nest. Then I transform it. I move it to the position where it was nested. Then the same with the leg. So I have my original leg here with all these little details, and it gets positioned, it gets moved where it was nested, so that I don't get just the simple one, but actually the one that I want to nest with all the details that I want for the production. And the same for the riffs production, where they get moved to the corresponding position with all the details, including, for example, here I have the number of each of these riffs, so that when the piece of furniture gets built, then you know exactly where you're going to put each of these riffs. Here, of course, you have also other options like placement, tolerances, rotations, etc. Rotation is how many times our object is going to try to be rotated in order to make the best fit. So in this case, I'm just saying it's going to be rotated 2 times. So that means it's going to be in the 0 degrees rotation, and also you are going to rotate it 180 degrees. And I will say 4 times, that means it will be in 0 degrees, then it will be rotated 90 degrees, then another 90 degrees, then another 90 degrees, and then of course it will take longer to compute, but then probably will give us a more optimized, like material optimized definition output in our nesting. So that's for the nesting.
Yeah, there's a few questions about it, so maybe spend 1 minute.
And what was the first of all the answer of our poll?
I didn't see. Yeah, a lot of participants are used to it, but I think anyways your explanations give a good idea of what it is, even if they are not working with it. So that was good. So the first question is, can you specify the minimum space between parts, or do you need to make parts bigger to account for that?
So here you have a spacing.
Yeah, it's a spacing option, right?
So you can give here, for example, I have 10 millimeters, so I'm giving 1 centimeter between the pieces.
The second question was, why are polylines faster than NURBS curves? That's a NURBS curve has a lot of information in it. So, but basically you can evaluate the curve at each point. So it's just a lot more information to compute nesting or any operation. Also, if you do curve containment, for example, if you test if points are in a curve, if you test in NURBS curve, it's going to take a lot longer than a polyline, because a polyline basically is a series of lines, and it's very cheap to compute whether a point is on one side of a line or the other side.
Yeah, a polyline is a list of points. Yeah. Whereas a NURBS curve is an actual mathematical expression to create this representation of the curve.
Yeah, so polylines are always good. So of course you lose a bit in precision, but you have to make sure that you have enough. Or for example, for curve containment, especially if you don't want to miss points, you have to get the containing polyline and make sure it doesn't miss anything. But anyways, I'm going a bit off topic here. But yeah, that's the idea basically.
Yeah, and again, as I show here, it's not just that it gets converted to polylines, but also that I get rid of all the little details that our nesting doesn't need to have. And then all of these details get anyways applied here when I actually use the transformations to position my final pieces.
Exactly. So in this case, using polylines, as long as you make sure that they don't lose too much the information of the initial geometry, the only drawback is that maybe your solutions are not as optimal as using the real geometry. But if they're precise enough, the polylines, then you get really good results with them. There's a last question, which is a toggle to turn on off nesting calculation in Rhino, or can it be used to control the nesting in ShapeDiver? If so, can you please explain in more details? So maybe you can go back to this.
Yeah. So this toggle is a normal Grasshopper toggle, and what happens is that I take this true false toggle, and then I break my definition in strategic places where I know that, for example, here I break it. I use a filter. When I know that if my process nesting is false, then my filter is going to send no information to this group, for example, where I'm creating columns for production geometry. I don't need to process this until the end of my definition. And the same happens here with the creating risk. So all of this production and nesting group, with this big group, has different filter components that when the processing is false, all of these gets deactivated. So for example, here, all of this gets break, and therefore none of this information is sent to be processed in this group, and therefore we can save computation time. So this is how you turn off and on parts of your definition to avoid processes that are not necessary in some parts of the design process of your online application. The same happens with the 2D drawings that we will start talking about in a bit, where you can also, if you are using the Make2D component that Grasshopper now offers, the Grasshopper in Rhino 6 offers this new component. This also normally takes a while to compute if you have a very complex geometry to compute this 2D shape. Therefore, you also need a toggle here to turn off this part, and then this toggle that we have here, gets converted, as we saw at the beginning, gets converted into this toggle that we have here in the online application, where you actually do process nesting to true, and then you go download production files. After you process your nesting, you can go download the production files. Now, this is of course directly here that we are in the ShapeDiver in the ShapeDiver like raw product, in the ShapeDiver raw UI user interface. But if you were to create your own UI, your user interface, of course you don't need to show this process nesting toggle. This is just something that you will use internally in the back of your application, and then you automatically, for example, when somebody say, okay, I want to buy this, and I go buy now, then when they click in buy now, you automatically in the background activate this toggle. You go this to true, of course, via the API, and then you will, after this happens, you will download the production files. This is just how it gets shown here in ShapeDiver, but of course, if you want to then put this into your own website with your own UI, then you would create your own way of using all of these parameters. Okay.
All good for questions?
Okay, we can move on. Perfect. So until now, here we have now all of our files nested, all of our curves nested. So we have all of them here nested, and then with the sheet, the size of the sheet where we are gonna put all of our pieces. This is just a rectangle that gets sent here to this OpenNest component. And then here what I do is I use the end-wine component because I want to, so now that I have everything nested in the right position, now I want to start grouping everything in layers and colors. So with ShapeDiver, we have some components that allow you to put information inside your geometry that then gets translated, of course, in the files that you can download. So for example, here I know that my branch 0 is my layer 0. So I have here actually a list of colors and layers. So I have it here, layers and colors that I'm gonna use. I'm gonna just take them from here.
Edwin, maybe just you have the same black areas on your screen as last week. I don't remember if you could solve it.
There, better?
No, we still. Yeah, that's better. Yeah, you still have one on top.
Yeah, that's the camera. I don't know how to. Let me
Okay,
see.
well that's better, anyways. Yeah, you can go.
Now?
Yeah.
Perfect. So I have this list of layers and colors. Of course, this could be also a parameter if you want, so that if you want this to be as open as possible, you could give a parameter here where people can add which layers they need and which colors they need. In this case, it's just hard coded here as a list of 5 colors and a list of 5 layer names, and that's the same order that I want to put here. So I know that my branch 0 is everything related to the stock, my sheets of material. Then the next one is the engraving. So here I can see if I put data, I can see that my second layer, the one that I'm connecting here, is all related to the numbers. So I can check here all the numbers here, here. Then all of them are the second layer. Then the third layer is related to inside cuttings. The next layer chamfer, and the last layer the outside cutting. So all of this is what happens at the end of our CNC machine. The last thing that would do is to cut the complete pieces out of our material. So that's why I'm grouping here everything. Of course, here I know the order of my list because I'm creating my geometry. So I know that first of all I have my curves related to the outside cutting, then I have my curves related to the chamfer. All of that I have already organized, and that's why I can, when I come to this step, I know exactly how I have to split my information, and then regrouped it in a different way. So I have now here my tree with 5 branches. These branches are going to be the colors and the layers of my final file. And then here we have 2 components. There are here in the outputs components. Here we have the ShapeDiver properties export and the ShapeDiver set properties. So the first one, the ShapeDiver properties export, creates a set of properties that you can then bake in your geometry. So for example, here we have layer, name, color, and plot weight. So here, for example, we have the layer colors, the same way that we have here, and the layer names. So I end up with 5 properties, and then I also have 5 branches here. And then is when I use my ShapeDiver set properties component to take my 5 branches and bake into these branches these properties, these colors that I know, and these layers that I know. And then this final output, which contains the geometry with the baked information, is what I use here to download the production files. This is the ShapeDiver export download that we saw. Then I give here the production file format, in this case DWG, but as we saw also, I also give the option where you can select which format do you want it in, and then just a name for our export. Here I'm using FabTools, FabTools just for local testing. This is again just for local testing, because here I can see how. So with the same order that I have of my layers and my tree with separated into layers, then I can see how the final result is going to be locally. I can test it, so I can see that everything has the colors that I want, everything is in the order I want, with the right information. And then when I upload this into ShapeDiver, then I get these download production files, and I go click. Then I go download. Of course, as you change your model, your production files will be reprocessed, and they will look different depending on how your model was set in the online application. And then you can download your production files. And then here, for example, we'll see the final result, where you can, and then you have already here your production file ready to be cut in the CNC machine. And this is, of course, done automatically. So we have just automatized the process of nesting all your production. That's for that part. Any questions so far?
Yeah,
All
there's
good.
one question about how you created the number labels for the cut parts.
The labels I used, there is different plugins that allow you to create text curves from text. For example, FabTools has some of them, so text contour, but also Squid has its own component, text curves component. So I think here, let me see, where do I have it? Oh no, that's not the part of production. Part of production is here. So creating ribs, I should have, where is it? Part where I do these labels. Yeah, but basically I just input the information of my numbers, and then as output I get all the different numbers. Yeah, here I have the numbers. Here I have the rif table numbers. Okay, yeah. So I have the rif tags. What I did is I just internalized my tags. That's also for optimization purposes. So here I'm using the text cubes component of Squid. So I'm using this text curves component, is here. And then I'm using these other components here for creating my text as curves. So if I enable this, enable, then I'm just creating numbers to 99. I mean, this could be also automatically done, but what I did is just internalize my curves so that they are not all the time being created on the fly, but they are actually just already there to be used. So this is also just for optimization purposes. You could of course connect this directly and set here exactly the amount of pieces that you have in your the amount of riffs, for example. But here I just internalized so that we don't have to create this geometry from scratch all the time. And then here I'm actually using this font. This font is the one that allows that our curves are just with one line, so they are not like thickened curves. If I go to Arial, for example, so if I take branch 0 of this one of the branches basically. So let's go branch 3. So you can see this is the number 4, but it's a single curve that allow me so that the engraving happens fast. Because if I go, for example, Arial font, then it will give me double curve here that is not optimized for the CNC machine to do this engraving as quick as possible. Yeah, so that's hope this answered the question.
Yes, so there's actually follow-up questions to this because users say that they would like to use actual annotation text. Some CNC machines support text directly, and actually in this case you can use FabTools, right, to add them. You won't see them in ShapeDiver, but for the export it's going to work, correct?
Yeah. Well, unfortunately, FabTools is a third-party plugin, and it hasn't been updated for Rhino 6 because I think you could create an dimensions or a text tag and this will be exported as a text entity, not as pure, but actually as text. So here we have it. Which one was it? One of these, and the problem is that this is FabTools hasn't been updated, and sometimes it doesn't output the information that you want. This is still giving me text. I think it's this one. Yes. So here, this one will give you as output text entities. So this is basically gets exported as actual text that you can change normally in the
exported file.
Yeah, in the exported file. But here, unfortunately, because this hasn't been updated, this FabTools component hasn't been updated for a while, then it is no longer supported by Rhino 6. However, we created a C# script that does support this. We can share this C# with you. And then this C#, you can input the information that you want, and then you get this text entity that you can put here inside your export, and it gets exported actually as text. which is really convenient for some purposes.
Mm-hmm. Yeah, someone also mentioned that if we support elephant, which I think we will in the future, that there are some annotation tools as well in there.
Yeah, there's some annotation tools here. Mm-hmm. Okay, any other question? Let's continue.
We can continue for now.
Yeah. So now that we have all of our production files as curves and everything, now we want also other kind of files. So for example, here I want to produce the 2D drawings of my table. So I want to produce maybe a elevation view and an isometric view. So for that, we can take advantage of the Make2D component of Rhino 6. This is new in Rhino 6. With this, you can create from a 3D object. You can create actually 2D views of this object. So for example, here I have this bunny, and then I want to create an isometric view of this bunny, for example. So when you add this component inside your canvas, that is inside the display component, and here you have the Make2D component. This gets as default this compute below here. So when you have ready your component, you can go compute, and it will give you here the final view as curves, as a planar curve that is basically an isometric view of our, in this case, a perspective view, because I'm using the Make2D Rhino View. I will explain a bit. But the very important thing to have into account here is that you have to go right click and go to automatic, because of course here you have this clickable button in Grasshopper, but of course if you have this in an online application, nobody will be able to directly click on this in the Grasshopper definition. Therefore, you need this to be automatic, so that every single time that something changes, this is automatically being processed. So for that, okay, we have our geometry in our geometry input, but we also need a camera view. So we need to know from where we are trying to create this view, from the top view, from the perspective view, from the left view, front view, etc. That's why we have here the Make2D Rhino View. This basically takes one of the viewports of Rhino. In this case, I'm taking perspective. And from perspective, it gives me the result. If I go here, for example, top, that means it's going to take my top view of my 3D object, and it's going to compute how it looks from the top. This is good if you are using again this inside Grasshopper, but if you want to use it for an online application, we cannot access the Rhino viewport. We cannot access this Rhino viewport because everything has to be living inside Grasshopper. Therefore, there are other options like the Make2D parallel view and Make2D perspective view, where you actually give us input a rectangle, and that is basically your camera. So it's basically like if you had your camera, and then you know exactly where you are looking at and how, because of course you have this parallel view, but you have also a perspective view. So then you can also give it the point where it starts the perspective view, and then the frame also. So for example, in my example of the rifts table, if I activate the process 2D drawings, I go through, then this will create my 2D drawing. Let's come here. Here I have my two views. So I'm using Make2D parallel view. I can see here my two views. So this component let us know how our camera is oriented. So these rectangles, how are they oriented, and to where they are looking at. So you don't want these arrows to be looking to the opposite side, of course, because there is nothing. You want it to be looking at your object. So here I have my object, that is this mesh. This mesh also doesn't have all the details, so it doesn't have the notches, for example. Here, this is complete if you go Control M inside Grasshopper. None of this has the notches or any of the details for manufacturing. Again, to keep it as simple, because the simpler the geometry, the faster it will compute. So we don't need any of these details for our Make2D component. And then this is our camera. So this is how it is, how our camera is looking at the object. So this is just a rectangle that I position in the space based on the size of my object. So for example, here I use these bounding boxes to get my rectangle and my views. And then with that, I input this in the views input, and I have my geometry. And with that, I get as output my Make2D as curves. Here I have the curves. And then I can start to, of course, position these in the space. Here I position them one besides the other. And then I can convert this into a bitmap. The way to convert this into a bitmap is using, again, the Squid plugin. And then here we have the Squid plugin uses some instructions. So the instructions are well, the instruction that you will give to the Squid component that we have here, Squid, to start to draw this image. So for example, the basic one that we're going to use here is the draw instruction, which takes as input some curves and also some outline. So this outline component is here, outline component. And then here we have the draw component. So we are going to draw some curves with this outline, which has this color and this thickness. And with that, we can create the instruction of drawing all of these curves in a bitmap, which gets inputted into the Squid component. So here, for example, here we have other instructions like creating also some dimensions, creating some. Well, so here first we clear our bitmap. Clear, that means that we paint everything in white. Then we draw our curves. So we draw all of these curves in our bitmap, and finally we create the dimensions. The same order that you have here is the same order that everything will start to be painted one over the other. So you have to be careful with the order of your list here. And then you give here where your bitmap is. So the size of your bitmap. So I have this rectangle. And then I have to make sure that my rectangle contains the information, can contain all the information that I want. And then I put that in my rectangle input. Then I have my Squid instructions. And then that gives me as output a bitmap that then I can download via the component that we already saw, the ShapeDiver export download component, which can have this image format and this name, and that gets converted here in our online application into this clickable button where you can go process 2D drawings, and then you go download 2D drawings. This gets processed, and when you go download, you can see here the final result of the drawing with that it could be used, for example, as a summary bitmap, as a summary image that the clients can have, where they can see the different views of their model.
Quote, for example.
Sorry?
On a quote, for example.
In a quote, for example, yeah. And that's it. So with that, we have already go through all the production of our files, the exports. Now we can input information in our models, extract information from our models, automate production processes through nesting or even quotation processes through the creation of bitmaps. And we will even start supporting PDF formats. So you will start to be able to create PDFs, something similar to like with the Squid. So you will be able to use the Squid component, but instead of outputting bitmaps, you will be able to output PDFs that people can download. So you could automate, for example, the creation of the instructions for building a piece of furniture or a piece of jewelry or anything. So for automating the documentation process also of your products.
Exactly. So there were some questions about this. The PDF export is our very next feature, the next one we release, hopefully next week, but in any case, in May, by the end of the month, for sure.
Okay, well, we're already using it internally, so we already have it. We're already using it, and we are testing it. Of course, we need to make sure that everything is ready to be released to all the users.
All right, so thanks, Edwin. That's the end of the last session of the webinar. So we'll jump to the questions right after, and we can stay until, for half an hour for any questions you have about these last topics or any topic that we covered in the 3 days. And before we do that, just a quick last note. So again, thanks to everyone who joined. That was amazing to have so much good feedback. We'll have more webinars in the future, probably covering other topics, the API, building web applications, but also maybe just more focused on ShapeDiver itself than global cloud computing principles. And And one last note as well is that, you know, if these concepts make sense to you, if you feel comfortable, if this is a way to work with Grasshopper that interests you, we're always looking to extend our network of like Grasshopper Grasshopper designers and developers, and maybe work on projects with us. So that if that's something that you're interested in, you know, you can be in touch and we can discuss. But yeah, so thanks again. And now let's look at the questions. We already have a couple. Does Make2D Rhino View work for named views in Rhino? So, because, you know, Edwin, I don't know if you know, but if you again call a Rhino view, there's two ways to call a Rhino view. There's by calling a viewport, which is live, but also with named views. Yeah, exactly. But so that could be, you know, on paper, that could be a good way to, you know, save a named view basically and use it in Grasshopper. But the problem is that named views are not stored in Grasshopper; they're stored in Rhino. So, and really, it has to be contained in Grasshopper if you want to upload your model with it. So that's why even named views, we can support them on ShapeDiver.
So that's why you will use these other components that where you actually create your, let's say, your camera from scratch.
Exactly, builds the whole view directly in Grasshopper. But actually, that's also a topic that we'll develop a bit and give more control over this, especially with components that allow you to control the view, like set some view settings in the online viewer, but directly from Grasshopper. So that's a set of components we'll add at the point. So someone is asking, let's say I have a folder with images, those I want to use in Grasshopper, but only one or two chosen by the user directly or indirectly. Could it be possible? I'm not sure I understand completely the question, but I think it's about internalizing bitmaps in Grasshopper. So maybe you could show that quickly because you didn't mention it yet.
Yeah, actually, the good thing of this bitmap component that we have here is that it is now a primitive. So if you go here into parameters and you go into primitives, you actually have a bitmap. If you have the ShapeDiver version of Squid, you will get this new component here, which is the bitmap component, and this is the same format that you get here as output. You could also do it through images that come from other parts. So this is an example where you can input here your bitmap. You can go right click and internalize this bitmap in your definition. So now this bitmap lives inside Grasshopper. We can do the same here if we go to our third day. Here you can do the same with the images that we were importing from outside of Grasshopper. So for example, from this link, then we get as output a bitmap, which is the same format of this primitive bitmap. And then we can also take this input, go right click and go internalize data. And then you have now here internalize your bitmap so that, for example, you have, as you mentioned, this list of bitmaps that you want users to be able to select from a drop-down menu, for example. Then they have them here. And you could, for example, have a custom bitmap inside your value list, and then they will go through some example bitmaps, or they go to custom and then they can upload their own bitmap.
Exactly, yeah. So we have questions more basically. Well, now it's questions that are a bit not directly about the webinar, but about ShapeDiver and business model. So interested in the business model for me to be able to set up custom manufacturing with a local fabricator. Well, I mean, you know, you can get in touch maybe with us or talk about it on the forum, because I think it's interesting for everyone. But there's a lot of ways this could work. One way we want to grow the platform too is that to let the users monetize a little bit their creations and their algorithms. But in general, what you're talking about is almost what I like to call algorithm as a service, where you could upload ShapeDiver models and monetize, you know, the exporting files from the configurators per se. So, you know, you give control to people who don't know anything about manufacturing or about CAD operations. but just with a few sliders, they can export a custom manufacturing file and then produce it locally. Exactly. So that's one of the big the topics that are very important for us, is that you can really manufacture locally. You design globally, but manufacture locally, and really decentralize those operations. So there's a lot of ways to set this up with ShapeDiver. I don't know, Edwin, if you have...
That's really great. Like this new way of I mean, this is a new way of selling your design skills. So now you are not constrained by where you live, because now you can, as Matthew said, we have some designers that they are like really good designers, and they just need to make your design parametric in this case, and automatized. So they just have this very well done Grasshopper definition where everything is parameter and automatized, and then they put this design online, for example, with ShapeDiver, for example, and then everyone in the entire world can access this file, can access this parametric, for example, the parametric rips table. They can tweak it as they want, and they can download the production files and go to their local CNC fabricator and then cut it in locally, instead of having to contact the designer and all of that. So the designer is now automating all his designs, his production.
Yeah, exactly. So I mean, that's clearly the type of business models and workflows that we can help with. So for sure, get in touch if you have some ideas about this. We have a couple of more concrete questions now. So let's get technical a bit again. So even if I have a folder with 200 images, should I internalize all of them and after let users choose these images? So of course not. If you have so many images, what we just showed with internalizing images is not the best option. In that case, it would be better to store the images somewhere online in an online location, Amazon Bucket or Dropbox or whatever, and then just either have the list of URLs in Grasshopper. But if you already have 200, you should use a scheme. So basically concatenate, like the beginning of your URL, and maybe, have a naming scheme for your images that you can basically build the URL inside Grasshopper and then use it for your image.
So for example, you have your image stored in www.example.com. And then here you could go concatenate. And then here you could put this here, and then you could here have a value list, where you could put, for example, 1, 2, 3, I don't know, 1, 2, 3, 4. So here you can put select your image that will appear as a drop-down menu. Then you can put this here, and then you can put that the last extension of this is .jpg, and then with that you construct your final URL. Here I have my final URL where you have stored your image. So this is this should be an existing URL where you have your image, and then that can come here and then be downloaded by our component, and then you can then continue with the process if you are going to process this. But you could also do the second option, that is you actually have a text input, the one that we show here, and then in this text input you can input directly the links that you want to get. And in that way you can connect all your database with whatever amount of images that you have. It doesn't matter for us. It just matters that you send a link. That's all.
Yeah, exactly. So in that case, the drop down, like the list of options, would have to be built completely on the website side and not inside Grasshopper. Now we have a couple of questions that are related to a topic we didn't really discuss in the webinar in detail, which is texturing environments. So let's try to answer them the best we can now. But just so you know, we have specific tutorials on the YouTube channel about this. I think it's episode 2 of the getting started webinar series, YouTube series. So here we explain a lot in details what you can do with textures and everything. But let's look at the questions. So can you define texture maps within a ShapeDiver script? curious whether there are efficiencies for representing complex patterns like cutouts as textures with transparency rather than meshes. So actually here the question is about basically working with maybe simpler meshes and using textures as for some detail, like for representing some geometric detail. Actually, yes, of course you can do that, because with the ShapeDiver materials, so like Edwin is showing in episode 2, we discussed this topic, but with the ShapeDiver material components, which you can use instead of the standard Grasshopper custom preview and material. You can actually input a list of textures, so not just image texture, but also roughness, metalness, and normal map. So especially with a normal map, you'll be able to fake some geometric details, of course. That can especially work for engraving or these kind of things, but even for some. So for example, here you're talking about the cutouts here of the table. You could definitely have textures that modelize the cutouts nicely, I guess.
Yeah, in general, I mean, here we explain more about texture in our YouTube videos, but here the basics is that we have a ShapeDiver display geometry component, which supports, of course, a geometry as input, and then has a material also as an input. And then here, as material, we have two options. We have the option of ShapeDiver simple material or ShapeDiver material. With the ShapeDiver material, you are creating your material from scratch. So you are giving a color, you are giving a texture, which can be which is a URL or a bitmap. Like you could create, for example, a parametric bitmap with the Squid, or parametric bitmap with a Squid, or you could import a bitmap from outside with our components, and then put this as a texture. You can also metalness, roughness, etc. All the channels that are material normally need. And for example, metalness supports, of course, a number between 0 and 1, but also a URL. So you could have also a texture map of how your metalness look, your roughness looks, etc., etc. So all of this is explained also here. For example, in this tutorial, we have how we did the texture mapping for this table. But also, if you go to shapediver.com/blog, we have a part where we talk specifically about texture mapping. So if you go down here to ShapeDiver Basics, here we have ShapeDiver Basics, here ShapeDiver Basics, and then here we have one part where we talk just about texture mapping. Here, texture mapping explained. And then there we talk, we see how to fake, for example, this is a simple sphere, but we are faking this texture, with texture. So this is just a sphere, but with this texture, we fake that it has all of these little details.
Exactly. Okay. Yeah, we have one last question, which is again a bit technical. For customizing the environment, I read the tutorial. We can use Amazon S3 and Dropbox, but how is it possible to use multiple pictures from the same folder in Dropbox? I'm not sure, but actually I think, the problem with Dropbox is that it creates custom links for everything you upload there. So the download link will always be, it's not going to follow a scheme you can control, basically, I think. I'm not too familiar with it. So if that's not possible, then S3 is your best option, or any server where you can map an actual URL you can control, and control the scheme, the URL scheme for all the pictures that are in the same folder. So that would be more efficient in that case.
There is a question, kind of question. I don't know if you saw it in the chat.
The long one?
Yes, I don't know if you want to answer
we can finish with this. Maybe I'll read it. But can you tell us how is your company growing in terms of markets, and what do you think will be the next technical biggest challenge for the next few years regarding your technology growth, like 5G, or maybe faster coming web languages, or maybe Grasshopper 2? I would like to have a future vision of your company. So there's a lot to unpack here. But okay, so first topic about markets. Clearly, if you followed what we've done in the last few years, our initial market has always been e-commerce and product configurators applications. But of course, since we provided a tool that's useful for the Grasshopper community in general, we've seen more and more different uses of the tools that we built with ShapeDiver, and more we have people involved in collaboration that involve ShapeDiver in collaboration workflows, to work with remote teams, and to basically streamline any type of workflow, of design workflow, where you have stakeholders, people involved in projects, project management or product management, which don't know how to use Grasshopper, or don't know, are not so close to the design process, but still need to take part in decision making. So basically, the idea is that we will soon develop the platform to represent and support more this type of uses, rather than just having a platform where you can upload models and embed them in a website, in an e-commerce website, which was the initial focus. But that's in terms of market. Then we want to basically cover more use cases for the entire Grasshopper community, would be the short answer. In terms of technological challenges, we try to stay close to everything that's coming up in terms of web technologies. So, we are in the process of defining exactly how we're going to integrate augmented reality, for example, and how to really make it useful in the context of parametric models. So really interact between an augmented reality environment and Grasshopper. So that's one thing. Other things that we're looking at are, like web assembly or other ways to basically improve the communication, the interpretation of a parametric model in Grasshopper, and convert it to like an object in a web environment, basically. So here, the idea is really to optimize the communication, how fast, how responsive models are, and all these type of topics. And for the last thing that was mentioned in the question, which is Grasshopper 2, I think like everyone, we're looking forward to Grasshopper 2. We try to see what snippets, some teasers that David drops on the forum, and try to get an overview of where it's going. But basically, you can be sure that as soon as Grasshopper 2 is here, we'll be on top of it, and it's going to be compatible with ShapeDiver. Yeah, that's not everything, but let's say that's an overview. But if we look at more like shorter term answers, as I said, PDF manipulation and export is coming very soon. And after that, we're going to be looking at a couple of really big plugins. I'm not going to say names yet because it's not 100% sure, but really plugins that a lot of the community is using, we're going to start supporting more. And in general, we are working on tools inside Grasshopper, so in the ShapeDiver plugin, that will allow users to control more stuff online. So even, talking about stuff that is only available in the API now. So for example, what Edwin is showing, drag and dropping points in the viewer and updating automatically, but also, creating animations. For example, if you have furnitures and you want to interact with the product, open doors, drawers, or, move stuff around, move shelves around, this kind of stuff, it's already possible with the API. But the idea is that we want this logic to be available to Grasshopper designers directly in Grasshopper. So the idea is really to use Grasshopper as an engine to create a full web application with everything that can be offered once the model is online. So this, you can expect several releases of the plugin this year with more and more support for this type of operations.
Yeah. Yeah, here just what I'm showing is something that some of our latest updates is still just in the API, but it's one of the latest updates that we have that is actually snapping. So you can actually see that our point is actually snapping to certain positions. So this is one of our latest features where you can snap either to points or even to lines. So you could have a line and make your object snap to that line. Then well, that's regarding that. And then I also saw a question where they were talking about third-party plugins. So if you go to our support page, support.shapediver.com, then you can go to the ShapeDiver plugin, and then you can look at the list of supported third-party Grasshopper plugins. And all of these ones are the ones that we support. We support the vast majority of plugins. Some of them we have, for example, Human for texture mapping. Those who were asking about texture mapping, Human has its components regarding texture mapping that we support. And then we have other components here, Kanguro, for example, other plugins, Kanguro, Launchbox, Mesh Plus, Mesh Edit, OpenNest that we use today, Plankton, Pufferfish, that is a really good tool, and other ones. Weaverbird, for example, for those that are into the jewelry industry, especially. Yeah.
Exactly, yeah. And we have another more technical questions to finish on a good note. Do you have plans to have a sketching tool inside the configurator? So basically, it's a bit linked to what Edwin showed. Like with the API, you can already do a lot in terms of, like, let's say, more advanced UI than just sliders and drop-down menus and this kind of stuff. And we're actually looking into how far can we go in adding more custom objects. But one thing that is interesting to us is to see if we can in any way support the graph mappers inside Grasshopper. So you have a lot of different types of graph mapper, and it's not exactly sketching, but it's a good way to manipulate curves and have a bit more advanced control over your geometry. And we're looking into the best ways that we can automate a bit the support of these graph mappers. So right now, if you have graph mappers in your definition, they'll be compatible. You can upload them on ShapeDiver, but you just won't be able to control the graph mapper, of course.
For example, here in the refs table, I actually you have an explanation about that. If you go to version 1, where you have a version with the graph mapper, that is great for local testing because you can, of course, move your graph mapper as you wish. But as Matthew just said, we don't support it because of its complexity. Therefore, you can anyways kind of fake a graph mapper in the 3D view. So, for example, here we have this curve, and then we have a series of lines that go through this curve. So we are basically creating this same graph mapper, but in the 3D space, so that we can actually compute what we need, and actually, well, the users can control, as we saw, this curve through control points. Therefore, they can actually control somehow this graph mapper.
Exactly. So yeah, that answers pretty much the last question. I think we'll leave it there. So yeah, one last big thanks to everyone. We still have a lot of people who listened until the very last minute. So thank you, especially to all of you. And yes, so I think Edwin will post the very last files on the forum now.
Yeah, we'll include what we have seen today, and also the last version of the refs table, so that you can go through it and go through what we've seen. And remember, we will also post this video in mid-May with the webinar, so that you can go back to it if you need to.
Yeah, a lot of people have said, it's a lot to absorb. I'd like to go back to it. So definitely you'll have that very soon. And yes, and we will probably have more webinars because we like the experience and we had good feedback. So yeah, expect some more editions with different topics, especially about the API for the ones interested. Yeah, so thanks again. Bye-bye, everyone, and hope to see you soon on the forum or anywhere else, and hope you have fun with ShapeDiver.
Thank you, everyone, again for coming today, and see you in future webinars. Bye-bye. Thank you.